Okay, so big giant number 8. We are starting with number 8. Okay, a particle moves. We've got position x and y. We want to know in which direction the particle is moving as it passes through the point 3, -2. You do not have a calculator. So you need to know dy dt. dy dt is 2t. And then you need to know the time that it is at this point. And that will tell you whether you are moving up or down. I'm going to come back to the time at that point. You need dx dt. dx dt is -2. I don't need to know a time for dx dt. -2 says I am moving to the left. This is very important for you to know about your two-dimensional motion. Your direction of motion is found through dy dt and dx dt. dx dt tells you left or right. dy dt tells you up or down. We have left. That means you're gone. It's down to these two. And, you know, if you can't figure out how to find the time, guess. So here's how you do figure out the time. You have an XY pair of points, set them equal to this, and figure out which equation is going to be easier to solve. So the x coordinate 3 is equal to 5 minus 2t. You could also do the y coordinate -2 is equal to t squared minus 3. The linear one will most likely be easier to solve, but you know, it's your choice. Solving for t, that's going to be 3 minus 5 is -2, divided by -2 is +1. So I'm getting t equals 1. And you can double check in the other, but I'm just going to keep moving. When time is 1, dy dt is positive, up. That is letter A. I need to double check because, oh shoot, I need to go to the one video and say that the answer was said incorrectly in the video, and we discovered that after the video was done. Never mind. One of the videos that I made earlier today, it has the wrong answer highlighted at the end, and after I stopped the video, someone said, that's not what I got. And then I was like, oh. Whoops. So now, that was number 8, correct? Letter A. Letter A. Good. All right. Now, 11. This is for the video. And then, okay. We need to solve this indefinite integral. So we do have the plus c on the end, but the big thing is, do you know the formulas? And let me point out that your variable is t. Let me really point that out. Now, highlight all the t's in the integrand. And take a moment to realize that e to the pi is actually a constant. Oh, did they do that? Yes. Yes, they did. When you integrate this constant, you're going to get the constant times the variable t. Now, the formula for integrating 2 to the t. Do you see this? No! No! Bad, bad, bad. I can't emphasize that enough. I honestly cannot emphasize that enough. Your temptation is to always use a power rule when you see something with an exponent. If the variable is the base, then yes, use the power rule. But if the variable is the exponent, no. You must use the rule for exponential derivatives. So if you have some base number to the power of variable x, and b is a number, it's a positive number, the derivative is a constant multiplied by the function itself. Exponential functions are the only ones whose derivatives are constant multiples of themselves. And that constant multiple is the natural log of whatever the base number is. So natural log of 2 times the function 2 to the t, and then a plus c, and that gives us one of these answers. Is that E? Yes. And I'm going to double check. This is number 11. Number 11 is B. Apparently I can't see. Oh, I know why. Do you know why? Do you know why I just screwed up? I took the derivative and we're integrating. When you take the derivative, you multiply by the constant. But when you integrate, instead of multiplying by a constant, you divide by that constant. And so I made the silly error, and you can see how easy it is to do that. Which is why I'm continuing to always check. B is the correct answer. Okay, now I believe we are heading over to, and I'm going to point out 17. We are now on 17. Boop. Okay. Oh, second derivative. When you're dealing with parametric second derivative, you have to remember there's a special extra formula because you need first dy dx. You have y with respect to t, you have x with respect to t. You are able to do dy dt over dx dt, and everything's fine and dandy. First derivative, dy dx, no problem. Derivative of t to the fourth plus 3 is 4t cubed. The derivative of t squared plus 4 is 2t. Hey, let's simplify that. Oh, look at it. It's so cute. It's just 2t squared. How about we just take the derivative? It's 4t and be done with it. Oh, no. That's the mistake they're wanting you to make. I don't know if wanting you to make is the right phrase, but you have to know before you even get started with this that when you see second derivative of y with respect to x, you're doing parametric or vector. That means when you do the second derivative, you are in danger. Because your dy dx is a single function with respect to t. You need to take the derivative with respect to x of your dy dx. So technically, if you do chain rule, if this is a function with respect to t, and what I'm going to do is, I don't see any f being used here, so I'm going to say that dy dx is f of t. And I need to take the derivative with respect to x. When I chain rule, I go, look at the cute little baby t. And then chain rule says derivative of mommy, give mommy her baby, multiply by derivative of baby with respect to x. Now, if you want to isolate t with respect to x, be my guest. Or make your life easier and be able to find the answer. So the fancy thing they do is instead of multiplying by dt dx, they divide by dx dt. Because you already found dx dt. Right there. So after you do the first derivative and maybe simplify, you are now going to take the derivative of that function. So to get d squared y over dx squared. Derivative is 4t, but I am dividing that by dx dt, which I already know is 2t. And when I simplify that, I'm getting the number 2, which is letter B. Number 17. Letter B. Yes, we are good. Then 18. You're an adult now. No, the multiple choice problems reached adulthood. Okay, 18. You have dy dt. Now notice, with respect to t, you are supposed to find y of 6. Now, actually, looking at this, they are not telling us, they're giving us y of 0 is equal to 20, just that alone, and we are finding y of 6. They aren't telling us who the input variable is. The only thing we're seeing is t. So if they aren't telling you who the input variable is, make it t, because that's going to be easier to work with. So you have a couple of ways you can deal with this. I'm going to show you a particular way. I need to know y of 6 when I have y of 0. Now, y of 6 minus y of 0 happens to be the solution to integrating y prime from 0 to 6. Take a good look at that. Fundamental theorem of calculus. Now I wrote y prime, that's dy dt. So what it's really saying is you need to integrate this. Now you can do a whole plus c, find the c, and then plug 6 in to find y of 6. But I want to point out this way because if you were in the calculator section, you would not waste your time integrating. And you would do exactly this, what is in front of you. So I'm just going to say this, stick with it. If you are given a value of the integrated function and you're looking for another value of the integrated function, do this fundamental theorem of calculus. Now, let's look at the integral of this function. Now, I need to do a u substitution when I integrate. U is going to be negative t over 2. That makes du negative 1/2 dt. Multiply the negative 2 to the other side. And now my integral of negative 10 e to the u, and then the dt changes to negative 2 du, because I am integrating this function times dt. Then I have negative 10 times negative 2, integral of e to the u du. Integral of e to the u is e to the u. Yes, there is a plus c issue, but right now my focus is just without the unknown constant. The u that I chose was negative t over 2. Put that back in. So my y function is that plus a constant, but if I'm subtracting two different y values, the plus a constant is irrelevant. You can go ahead and put a plus c and watch it subtract out if you like. Now, yeah. So when I plug in the 6, minus I plug in the 0, I am going to get, plugging in 6, 20e to the negative 3 minus 20e to the 0, and e to the 0 is 1. So now I have that y of 6 minus y of 0, which is 20, is equal to, and I'm going to write this as 20 divided by e cubed minus just 20. Oh, look at those minus 20s. Goodbye, minus 20. I won't miss you. And we've got an answer for y of 6. 20. Oh, they left it as a negative exponent. And question? 18 is B. Yes. Yes, question.
So on this one, I just integrated just the derivative and saw there was 20 e to the negative third. Didn't worry about the constants, so that was the only answer. Is that good to rely on?
Yes.
Okay.
Yes. With multiple choice, if you see a faster way to do it without doing the whole thing, that's what it's meant for with multiple choice. So any way that you see to more quickly come up with the answer without having to do the full work, that's a good thing on the AP exam. I'm going through the whole work with the videos to make sure that you're clear on the concept. But if you can get to that answer faster with correct logic, go for it. All right. Number 19. Okay. Oh, Taylor series. Who misses Taylor series? Oh, no hands? No? Okay. All right. We are given f double prime as a function. Now, the coefficient of x cubed in the Taylor series for f about x equals 0 is what? So, let's remind ourselves. The entire Taylor series formula is nth derivative at the center is 0. So that means it's actually a Maclaurin, divided by n factorial times x minus the center, but it's 0, to the n power. We want the coefficient of x cubed. When I look at n equals 3, this is going to turn into the third derivative at 0 over 3 factorial times x cubed, and I want the coefficient of x cubed. That means I need to know the third derivative of f at 0. And I'm given the second derivative, and I don't have a calculator. So I am going to take the derivative of my second derivative. Square root of blah, chain rule says that's blah to the 1/2. 1/2 blah to the negative 1/2. Give mommy her baby and multiply by the derivative of the baby. This turns into 3 over 2 root 1 plus 3x. Plug in x equals 0, and that's going to give us 3/2. So the third derivative at 0 is 3/2, and the coefficient is 3/2 divided by 3 factorial, which is 6, which is going to make this 1/4. Am I calculating correctly? 1/4, which looks like it is letter C, but I will double check that. Number 19, letter C, yes. Any questions? Was that fun? See? Taylor series is fun, isn't it? All right. I am now going to tell you we are moving on to number 20. If I can get the 20. There we go. Woo! 20! Making it into that Actually, it won't be too many years before all of you turn 20. Oh my gosh. No, don't think about that. Okay. All right. Listen. Radius of convergence. That's it. Not interval. Just radius. Now, you can do this quickly if you see what it... Let me tell you how you can do it quickly. And then I can go the long way also. I have n only existing in exponents. This is actually a geometric series. I want to look at who is to the n power, and I can actually disregard plus or minus numbers with that n exponent. But if n is multiplied by a number, that matters. So if you understand why this is okay, you can realize that this is geometric with a radius of x minus 4 over 3. This will converge if that absolute value is less than 1. And when I multiply the 3 over to the other side, I can see that this is telling me a center of 4 with a radius of 3. And all I needed was the radius, and so there it is. Now, if you don't see that when you look at sigma, and I know most people don't see that when they look at sigma, then you're going to go through the process of the ratio test. You're looking at the limit as n approaches infinity of the absolute value of, plug in an n plus 1, times the reciprocal, so we're dividing by the nth term, two divided by 2, bye-bye. 1 extra 3 in the denominator, 1 extra x minus 4 in the numerator, and the answer to this limit is absolute value of x minus 4 over 3, and ratio test says converge if less than 1. And then we're back to that point that we are at again. And I'm going to double check. Is number 20's answer C? Darn screen. Yes. Okay. That means, see, that wasn't bad, was it? It wasn't bad at all. 21. Hopefully my screen will stop being annoying. Okay. Alrighty. Both diverge when P equals what number? If you're aware of some certain things, you will quickly answer the number 1. Let me actually explain to you why I say that. I'm going to go to Desmos. I'm going to show you why I'm saying that. Okay. One over x has perfect symmetry. We are used to dealing with as x approaches infinity. We are used to the P series, and we know that 1 over x diverges. We know that if the exponent, such as 2, if an exponent is larger than a 1, we get a converge. If the exponent, here it is 1/2, for a P series, we know that that diverges. and that this is the border. There is symmetry of this trio to the x-axis in the same manner, but flipped to the y-axis. If you see this, this will save you so much time. If you are dealing with the integral from 0 to 1, you are dealing with the same exact picture with your vertical asymptote as you have with your horizontal asymptote, except the P series issue is reversed. And if you are integrating from 0 to 1, then having the P be less than 1 is actually converging, greater than 1 is actually diverging. Do you see that in the picture? It saves you time if you are aware of that, and that's why the answer should be just 1. Is that actually a good enough explanation? Okay, and then just to check, 21, answer B, we're good. Just after that problem this morning, I'm not moving on until I've got, make sure I got the right answer there. Okay. Oh, this goes way back. This goes way, 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 way back. Horizontal asymptotes are the result of not one limit, but 2 limits, and you need to not forget that. You need to take a moment to think about the limit as x approaches positive infinity and the limit as x approaches negative infinity of this function. Now, I've been talking to you about when you're looking at a limit as you approach n infinity, and you're dealing with polynomial over a polynomial with possible roots, that the quickest way to solve it is to take out the little plus or minus of lesser degree terms. Do you see that that minus 1 is not going to affect infinity? With that thought in mind, I put an equal sign with that understanding in mind. This is going to turn into this. Take a moment to look at it. Do you recall that the square root of x squared is not x? It is the absolute value of x. And if I'm dealing with a positive infinity and a negative infinity, I'm getting 2 answers. If I'm approaching positive infinity, I don't need the absolute value sign, and it's just 2. But if I'm heading to negative infinity, then think about it this way. You have negative huge number times 2 over positive that huge number. And so there are 2 horizontal asymptotes. The answer is D. And I remember seeing D when I was looking at the answers, so we are good. Oh, did I put that big number 22 before I started 22? Oh, shame on me, I didn't. 22, now 23. What happened? I don't know. Well, when you see that in the video, sorry, I didn't announce 22. There, announcing 23. 23. Oh, this is a good one. We want to find f prime of x. The answer to our integral is this capital F of x. They want us to take the derivative. F prime of x is equal to the derivative with respect to x of this function. And I'm bothered by the intersection with that and the answers. There we go. Now, you might remember how to deal with this, but maybe you don't. So here we go. Listen carefully. Let's say this function is, and I'm going to make up a letter that is not already used. So how about I use lowercase g? This is little baby g. Little baby g gets integrated into big old G. And I then evaluate it from 4 to x squared. And after I do that, I'll be taking the derivative. Now the integral says that I'm going to plug that x squared in, minus I'm going to plug that 4 in. And now what I have is, I want to point out, as soon as I plug a number into the one and only variable, that's a number. It is a constant. Its derivative is 0. New focus is just this. I need to chain rule my derivative. So I've got baby function, mommy function. Chain rule says derivative of the mommy. Give mommy her baby and multiply by derivative of baby. And now I have 2x times g prime of x squared. But if I integrated little g to get big G, what's big G prime? That's the square root of t. But I'm plugging in an x squared. Now, I just mentioned that the square root of x squared is the absolute value of x. The problem, however, says x is only greater than 0. So that means that that is just x, and my final answer is 2x squared. So know that when you're about to take the derivative of an integral in this format, if it is a constant to a function, really all you're going to do is go, hi, you're the derivative of the mommy function. And go, all right, the answer to the derivative is the derivative of the mommy function. This is the baby. Shove it in, multiply by its derivative. And then you get to that point faster. But you've got a lot of things to memorize. If you memorize this, memorize it through understanding. And it'll stick. So which letter did that give us? D? Let me double check. 23, D, yes. All right, 23 is done. I'm going to remember to change my number. 24. 24. Which of the following is the solution to the differential equation? This is going to show up. In fact, you are very likely to have to solve a differential equation like this in free response. And if it shows up in free response, let me tell you that it is a minimum of 5 points. It's a big deal when it shows up in free response. But you are looking for wording like find the solution to know that this is integration time. You have a multiplication going on between function containing x and a function containing y, multiplication or division. If you have addition or subtraction, it's not going to ask you to find the solution, I guarantee you. You don't have that technique yet. So you're going to integrate by separating the variables. You're going to multiply the dx over to the right side, and then you want to make sure to keep the x's on the right, but make sure that you make the y's move to the other side with appropriate operation. So take a moment to think, I have to divide the y to the other side, or even like do this to make sure, kind of thing. Because that first step is crucial. Now, we are going to integrate both sides. The integral of 1 over y is the natural log of absolute y. The integral of negative 2x is negative x squared plus c. Now, if you look at the possible equations here in your multiple choice, my recommendation is, if you are very, very familiar with what I'm about to show you, by the way, you are expected to be very, very familiar with what I'm about to show you. This can go faster, and the time allotted to the problems is with the understanding that you know what I'm about to show you. So watch very carefully. To get out of natural log, I e to the power both sides. Okay, why did you just decide you didn't feel good anymore? Silly pen. Now you have the absolute value of y is equal to e to the power of negative x squared plus c. Exponent rules, but you're used to them in the other direction. If you are multiplying two exponentials with the same base, you add the exponents. But you are doing that backward. The absolute value of y is either a positive or a negative y. Then I'm going to push that positive or negative to the right side. I'm going to rearrange this multiplication order. All right, 10 minutes left. And then you're going to recognize that this mess is just an unknown constant. I'm going to give it just another letter. How about a big giant capital A? Now, y of 1 is equal to 4. Let's plug it in at this point. So y is 4 when x is 1. And that means that this unknown constant is actually 4e. And most likely, they're going to bring this together. And again, when you are multiplying with the same base, you add the exponents. Exponent 1 plus negative x squared, and it is 4 times e to the 1 minus x squared. So if you are extremely familiar with this solution, you want to be able to actually very quickly go from, I'm getting this out of the way. Look at this. And look at this. you can quickly go from this being a negative x squared plus c as the answer to a natural log to y equals some unknown constant, not that one, but some unknown constant times e to the power of this number. And by the way, if you take a diffie-q's, differential equations class, this is the most basic of the problems you have to memorize of if you see this, do that. And I mean basic like, oh, you're so easy. Oh my goodness, just boom, 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 gone. Take a good look at that. This might help you a bit when you take the differential equations class as well. So there you go. Keep that in mind. And did I double check the answer on that? Or can someone just give me a yes, correct answer and I can move? All right, thank you. All right, next. Oh, I'm going to change the number. Woo, 25, 25. Oh, do you recognize it's so cute? Oh, look at that little cutie pie. You've got limit as h approaches 0. Does that h sound familiar? H on the bottom. And then if this is the answer to f prime of a, then this numerator is f of a plus h minus f of a. When you go into the AP test, you better know that formula. You should know it, live it, learn it, love it, understand the picture that comes with it and everything. Go back and study that. Now, I find it easiest when I look at that right end. I can now see that my function is sine x, and my a is pi over 3, and I need f prime of a. Derivative of sine is cosine, pi over 3, little unit circle thinking, pi over 3 is the steeper of all of these. X coordinate is 1/2. Now, you could use L'Hopital's rule on this as well. You have to realize, though, if you use L'Hopital's rule, the variable of your limit is the variable. Nothing else is the variable. So if you decide to go the route of L'Hopital, which is sometimes, it's often an option with problems like this, then you want to notice that when I plug in h equals 0, I get 0 divided by 0. Move on. That means the limit as h approaches 0 of derivative of the numerator with respect to h. Do you see any h's there? In fact, that's a constant. Derivative is 0. So now let's refocus on this because that's all. Derivative is, notice you have sine of blah. Derivative of sine is cosine. So derivative of the mommy, give mommy her baby, and multiply by the derivative of the baby. You're looking at pi over 3 plus h. With respect to h, derivative is 1. In the denominator, derivative of h is 1. And then you plug in 0, and you get the cosine of pi over 3. And you're back to the unit circle. So you've got two options when you run into those problems. But realize that the L'Hopital version is not always going to be an option, depending on the way that they present the problem. All right. We're moving, aren't we? 26. Dink. Okay. On which of the following intervals is g decreasing? You do not have a calculator. You need to find g prime of x. If you're taking the derivative of an integral, and the integral is just a constant to just the variable that you're taking the derivative with respect to, then literally the answer to this derivative is the integrand. Come on, there we go. Integrand, but with an x in it. You are expected to think about where this function is positive versus negative. We want to know where it's decreasing. Let me point out to you that this denominator is positive at all times. We're down to when is this polynomial negative? You're expected to think, how do I solve polynomial inequalities? I first factor in x in this situation, and then I factor more. You do not have a calculator, let me remind you. And then the solutions to that equation are 0, positive 3, negative 2. And you need to figure out which sections are negative of these 4 sections. Now, my question to you is, do you have, remember multiplicity? So factor x is to the 1 power. Its multiplicity of the 0 is 1. Multiplicity of 0 is 1. Multiplicity of the 0 is 1. You know what that means? This will change sign every time. And so you just need to figure out one of these sections and it's going to change sign. The only time you don't get a sign change is when the 0 of the factor has an even multiplicity. Then at that 0, it's not going to go through a sign change because it's forced to be positive at all times. So save yourself a little bit of time with that polynomial knowledge. I'm looking at the fact that this leading coefficient is positive, and then boop badoo badoo badoo, and I've got an answer of less than negative 2, and then between 0 and 3. And I will keep going until I reach 28 and then end this video and post it. Have a good day. Happy Tuesday. Hold on one second. Let me pause the video. (27) For number 27, we are given the function for f. G is the inverse function of f, and we want to find g prime of 1. Whenever I run into what is the derivative of the inverse, I go to a specific format. F and g are inverse functions, so I list them. And I create a table. And I look at what is the corresponding point. And then the slope. Now, I'm going to first look at, it wants to know the derivative of g when g's x is equal to 1. Then I want to realize that the corresponding point on f has y coordinate 1. And if I want to know the x coordinate that goes with f, I need to solve for this equation equal to 1. So let's write that down. Sine 2x plus 2x plus 1 equals 1. Now, the ones subtract from each other. What you're expected to do next is be very, very familiar with the fact that sine of 0 is 0. If I plug in x equals 0, I will get 0. Now, if I find the slope of f at this point, that means I'm finding f prime of 0. The derivative of g at the corresponding point is the reciprocal of what I get from that slope. Now, I have a function for f. I need to take its derivative. So, derivative of sine is cosine. Derivative of 2x is 2. Derivative constant is nothing. I need to find the derivative. Okay, stop doing that. I don't know why it's doing that. There we go. Plug in 0. And you are expected to be quick on cosine of 0 is 1. 1 plus 2 is 3. Reciprocal of 3 is 1/3. Be careful of making the accidental error of thinking negative reciprocal, because that's for perpendicular. These are not perpendicular. These are reciprocals. Okay. 28. Here we go. As I read all the words here, this word comes just boldly out. We want Lagrange error bound that guarantees that this difference is less than or equal to k. So let's break this down. I've got a third degree Taylor polynomial. And if you remember, I told you for Lagrange error, you're looking for your NAB, your NAB. It's time to go to class. Okay, the n is the degree of the polynomial that I approximate for. The a is the center of that polynomial. This says the Taylor series for f about x equals 0. The b is the number that I plug into x to approximate at. And it talks about it there, and it also mentions it here. I am approximating the third degree polynomial at x equals 1 to try to be equal to f of 1, but it's not exactly equal. The difference is the error. So my b is equal to, now class started, 1. Now with my NAB, I want to remember that the Lagrange error is the n plus 1th derivative at z divided by n plus 1 factorial times the x coordinate that I plug in, that's my b, minus the center of the polynomial, that's my a, to the power of n plus 1. You can also remember that you're going to 1 up your n and then almost do the Taylor formula. You're going to do the 4th derivative at z over 4 factorial times b minus a to the 4th power. And then your goal from there is to maximize this 4th derivative at z, where z is anywhere between the center and the number we approximate for. and we're trying to maximize that. Now let's go back and take a look. And it says, of the following, which is the smallest value of k, for which the Lagrange error bound guarantees that this subtraction is less than or equal to k. So that is the error. Now, what information do I have to help me deal with the maximum value that I can possibly get for my fourth derivative over this interval? I am given that this inequality holds as long as n is between 1 and 4 for all values of x. All values of x happen to include the interval from 0 to 1. So, again, fourth derivative, the fourth derivative of x is less than or equal to 4 over 5. So that's the largest that my fourth derivative can be. I have nothing else to plug in, just that's 4/5. And then the rest of it, 4 factorial, and then 1 to the 4th power is just times 1. And now it's just a matter of finding the right answer. And that would be it. Yay! Lagrange isn't so bad, is it? Or we agree to disagree.